The last piece of this section on energies is called Moving the Goalpost, which I think most of you know what it means. It's like changing the rules in the middle of a game to benefit one group or disadvantage another team or whatever. The section basically focuses on the evolution of geoengineering research and the reports that were written clandestinely at nuclear research labs and so on by people who are involved with defense and advising presidents and so on. And there is some stories about key players like Ken Caldera and David Keith, Tom Wigley, Paul Crutzen and so on, and how their thinking has evolved along the way, and how now geoengineering is actually being broadened in scope in terms of actually being considered under CMIP 6 called GeoMIP. That's essentially Geoengineering Model Intercomparison Project, which is parallel to the coupled Model Intercomparison Project, the CMIP suite of models that are used for IPCC assessments that come out every 7 years. CMIP 6 is out now. The concept on which this builds is called moral hazard. Here is a cartoon that's kind of a extreme way of exemplifying it. So here is a kid that's lost a tooth, and dad is giving him some money as the tooth fairy is supposed to do, and there's the wife saying, David, that's way too much. So he's giving too much money. The kid is happy. He says, the tooth fairy gave me $20, and then he goes out and asks his friend to bash him so that he can collect more money. So we are gonna be rich, says the kid with this bloody face, and all the kids have their tooth broken to make money. So the idea is that insurance makes people take more risks. Flood insurance makes people settle in floodplains. Banks giving risky loans make people behave in a risky way with the money they get, and so on and so forth. And the context in geoengineering is that even people who are not big believers in climate change can jump on the bandwagon of geoengineering, saying, hey, there is a solution, so forget about climate research, let's just fix it by spraying aerosols into the stratosphere. So you can go from completely denying climate change into jumping on bandwagons of geoengineering. As we mentioned before, the controversy became a little bit heated after Paul Crutzen, who shared a Nobel Prize for his research related to the reactions that create ozone holes, wrote an editorial where in conclusion he said, I think this was in 2006 in a journal called Climatic Change, the first modeling results and the arguments presented in this paper called for active scientific research of the kind of geoengineering discussed in this paper. The issue has come to the forefront because of the dilemma facing international policymakers who are confronted with the task to clean up air pollution, while simultaneously keeping global climate warming under control. Scientific, legal, ethical, societal issues regarding the climate modification scheme are many. So the idea that motivated Paul Crutzen to first order was that when you actually reduce air pollution, you make the air cleaner, which is good for human health and in the long run good for everybody, but temporarily it can actually reduce the scattering of sunlight and quickly accelerate the warming for a bit. So he was talking about compensating for that with stratospheric radiation management that we talked about. And this author, Oliver Morton, says he doesn't like solar radiation management, which was apparently a phrase coined by Ken Caldera to avoid calling it geoengineering and invoke all these oppositions. Okay, building trust between scientists and the general public would be needed to make such a large-scale climate modification acceptable, even if it would be judged to be advantageous. Okay. Finally, I repeat, the very best would be if emissions of the greenhouse gases could be reduced. That's the first goal. So much that stratospheric sulfate aerosol release experiments would not need to take place. Currently, this looks like a pious wish. This is kind of the motivation we used in the beginning to say maybe geoengineering is inevitable, and I am provocatively calling this course also, is geoengineering inevitable? The debate is fair, but one has to kind of make many choices in addition to ensuring not only that unintended consequences don't happen, but also that the disparities of the outcomes don't affect the most vulnerable, who are not basically involved in creating global climate change so far, and will not be able to protect themselves against experiments done by, let's say, a rogue nation on its own. Okay, so the two ideas that were considered in geoengineering along the way was, should it be a plan B, in which case you do a lot of research and leave it there, and if it looks like there is no way out without geoengineering, and then you pull it up. And the metaphor is break in case of hazard, where you have these glass encased fire equipments and other things where if there is immediate hazard, you are allowed to break it and use it to fight fire and so on. So is it geoengineering like break in case of hazard, where you keep it aside and wait to see when it should be pulled up? Then there are a whole lot of questions of how quickly it can be implemented, and then the other whole suite of issues like unintended consequences and termination shocks, etc., etc. Tom Wigley, an Australian scientist, came along and provided a different approach, what is called a breathing space approach, where the idea is to keep doing the experiments. So global mean temperature response to multiple volcanic eruptions has been seen. We invoked it in the case of getting out of the medieval warming into the Little Ice Age, for example. The standard eruption used was that of Mount Pinatubo, and eruptions were assumed to occur every 4 years. So this is a modeling exercise to emulate nature's experiments of geoengineering. Every 2 years and every year. The results are shown. The results shown are annual mean values plotted by year. In the second and especially 4-year cases, the forcing varies considerably from year to year, leading to noticeable interannual temperature variations. So you can see those can be analogs to high geoengineering, mid geoengineering, and low geoengineering with associated radiative forcing. And here are the temperature changes corresponding to Pinatubo experiments, and there is the termination shock, where after you turn it off, the temperature shoots back up. Right, so the cooling happens as you wish, as you planned, but then there is a jump. So the idea of the breathing space approach that Tom Wigley advocates is that you do these mild geoengineering experiments to give yourself space to properly design fossil fuel systems to be emission-free, carbon neutral, net negative, whatever you want to call it, till you reach the goals, and then you turn off the solar engineering or the geoengineering experiments. This sounds much better than this plan B approach, break in case of hazard. Of course, the concept is great, and it does allow you breathing room to keep engineering the climate to safely get to where you want to get. And this assumes that the emergency is going to arrive. Hence, you keep doing the geoengineering from, let's say, now itself to get to 2050 and 2100. But what if we don't do anything, and then some game changer like taking carbon dioxide out of the air and keeping it somewhere or using it comes along, and there is no emergency? Doesn't seem very likely. Again, seems like a pious wish, as Paul Crutzen said, but nonetheless, the two approaches are not quite exactly the same. Alan Robock wrote another opinion recapping some of the points we've already discussed, the hazards of the geoengineering. We'll just run through them. Effects on regional climate. We already talked about droughts, continued ocean acidification, because managing solar radiation with aerosols doesn't eliminate emissions, so the CO2 would continue to build up and acidify the ocean. Ozone depletion is a danger, as we talked about, but people like Jim Anderson and David Keith do keep doing little experiments where they are actually trying to understand the processes by which stratospheric mechanisms create ozone holes with aerosol injections, so that you are not only discussing this in a theory, but actually you have process understanding of the properties of the aerosols, physical, chemical, and optical properties, and their impact on ozone hole and so on. Effects on plants we talked about, maybe even ozone formation and crop yield losses. More acid deposition, acid rain, effects on cirrus clouds. The changes in humidity associated with stratospheric warming could actually increase cirrus clouds, which are greenhouse infrared radiation trappers. Whitening of the sky, we talked about the washed out look aerosols would give and make sunsets very beautiful and give you paintings like The Scream, but they would also reduce solar power. Environmental effects of implementations, we talked about whatever method you use, whether it's aircrafts flying or the balloon with a pipe being connected from the surface and so on. Termination shock, we talked about that, whether it's natural or man-made or end of policy support for continuing. There is no going back. These are one-way experiments where you modify radiation and you have set the Earth system on a different track, and then the Earth system has its own hysteresis and recovery time, like the carbon cycle, for example. Human error, always a possibility. Undermining emissions mitigation efforts. So this is the idea that people would just assume that radiation management and geoengineering are going to fix the problem, so we don't have to worry about reducing emissions anymore. Cost is always a concern. Commercial control of technology. Military use of technology. As we said, geoengineering has been considered for military strategies before, even though just in theory. Conflicts with current treaties, control of the thermostat. So if we decide that geoengineering is going to allow us to control the global mean temperature at some level, who decides what that number is, and how do we know the spatial patterns associated with this global mean? 2 degrees C warming target, for example, doesn't tell you how heat waves will change over India, or how extreme events will change over China, and the adaptation gaps in poor countries, and so on and so forth. Okay, so governance issues are big. Question of moral authority and unexpected consequences are always key considerations. Anyways, in terms of broadening the scope of geoengineering in mainstream activities under IPCC, GeoMIP is now being done under CMIP 6, which I mentioned already, to be coming out this year, but obviously may get delayed because of COVID. So we are using RCP 4.5, 6, and 8.5 here, which are the radiative imbalances at the top of the atmosphere, as you remember, with these representative concentration pathways, which are future scenarios, include population, science and technology, renewables, policy options, mitigations, carbon capture, etc. And at some point in 2020, the idea is to start in the models injecting about 8 teragrams of sulfur dioxide per year into the stratosphere and reduce the anthropogenic radiative imbalance, and continue till 2070 here, and then slowly ramp it down and see where we will end up in terms of radiation balance. And in terms of sulfur burden in teragram sulfur, This is the natural variability in the past, well, anthropogenic contributions from coal burning and so on as well. And this would be the additional loading. Here is where we are now, and additional loading would be 8 teragrams sulfur dioxide per year. Okay, so the goalpost has been moved in terms of geoengineering research, which is being done in many countries, especially Germany, US, and many militaries may be doing it without publishing the literature. The questions that we face still in terms of actual choices, implementations, and all the other issues that Alan Robach lists, we will go through in the coming chapters. Okay?